Hi everyone and welcome to today's video in this further math series on describing the centre and spread of symmetric distributions. Yes, so much excitement in one video, it's almost hard to know where to start. But we're going to start here by telling you, well, what on earth is this video about? This is part of the core data series of the Further Maths course over here in Victoria, Australia. If you are watching this throughout the world, then you're probably thinking, the Further Maths course sounds really complicated. It actually isn't. It's an awesome course. And pretty much every course throughout the world has some sort of statistical element. So watching this one will tell you not only what the mean is, but about the standard deviation and how that applies in future videos to something called the normal distribution, the 95 and 99.7 or 68, 95, 99.7 rule, and z-scores and whatever else. But we're going to start relatively simple. Now, by the end of this video, as I say up here, we will be able to calculate the mean, use the formula to calculate the mean, know what standard deviation is, find the formula for standard deviation, and move on to sort of far more exciting things. Now, if you are new to my channel, hi guys, I'm Darren, otherwise known as the Maffs Guru, and it's really good to see you. If you're an old hand at this, you know what's coming. Yes, if you are new, over there is a red arrow, and actually the thing that keeps me going are subscribers, and I would be deeply grateful if you could subscribe to my YouTube channel. It just lets me know that actually you're watching, and it's greatly appreciated. It's literally just me in a room trying to do a pretty big job here of recording all these videos. If you can, also shout out to your friends and let me know. Let them know that I'm here, also greatly appreciated. Now, in previous videos, and there are a number of videos of this series, we've looked at the mean, the median, the mode, and the range. And we've sort of said, well, some of those are measures of centre, some of those are measures of spread. And we're not talking about Vegemite spread here or Marmite. We've looked at the range and said, well, the outliers for the range tend to cause issues. And we came up with this other measure of spread called the interquartile range. And towards the end of this video, we're going to look at something else called the standard deviation, and that's really important in this video. But before we go further, let's go back. And recently, just before Christmas, I took 140 Year 7 students to the cinema to see The Grinch, the cartoon version, and actually it was pretty good. Barring the boys in Year 7 who thought it'd be funny that every time there was a humorous part of the film to overly exaggerate laughing. No, really not funny, sort of spoiled the film, but one day going to watch it again on my own with some popcorn and some Pepsi and life will be good. What's that got to do with the price of fish? Nothing. Now obviously the Grinch was known to be mean. And luckily there is no measure of meanness. There's not a scale out there for meanness. But in mathematics we do have something called the mean, otherwise known as the average. And it's the average value for a set of data. Now looking at the formula that I've written here, to be perfectly honest with you, there are all sorts of variations of this formula. But I think this is the one I like the best. The mean is given by the sum of the data values. And a lot of people are going to go, what does it mean by sum? Just add them all together. Divided by the total number of data values. So add them all together, divide by how many there are. Now we've done that since about year 8. By the time you're doing this course, you're in year 12. We've diligently done that, but how many of you have ever asked what the mean is? Why do we do it? What is the point of mathematics? Now, okay, I know, we all ask what the point of mathematics is. Don't be mean. Don't be mean, see what I did? No, anyway. We asked the last question, but to this day, I still haven't found a way of explaining what the mean is, other than to say it is some average value. It's a mathematically statistical way of finding sort of the middle value. Sorry, can't be any more help from that. If you do know, leave me a comment in the comments below, or leave me a message in the comments below and let me know. And we know that to find the mean, what did we do? We did the mean is equal to 2 plus 3 plus 4 plus 5 plus 6 plus 10 divided by 1, 2, 3, 4, 5, 6. When I add those all together, I get 10, 16, 21, 25, 30 divided by 6, which is then 5. So we get this average value, this mathematical average value that says the average value is in fact 5. But then we get to the point of, well, let's just work out what the median is as well. And what is the median? Well, that's the middle number. So cross one off the end and 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 find out that halfway between is 4.5. Now, obviously, they're not the same. So which mean or which average of centre are we going to use? Do we use the mean or do we use the median? That's coming up, I promise you, but it's a good question to ask. Now, Barry, we love Barry because he's sitting in that office trying to make maths even more complicated. And he's done it again. He's come up and he's gone, do you know what? I'm going to confuse everybody in the whole mathematics community because I'm going to come up with a formula for the mean that's going to throw everybody. And lo and behold, that's what he's done. He said x bar is equal to this funny E symbol, E, x all over n. And literally all it is just another way of writing long words as simply as we possibly can. So the first thing is, this x bar here, as I've said, with those arrows, means nothing more than mean. So when you see an x with a bar on top of it, it wants you to find the average. What's this E? Well, those of you who have used Microsoft Excel will know at the very top, when you want to sum all of those things together, you could highlight down the column, couldn't you? You hit the little E button and it added them all together. Well, that's literally nothing more than saying sum. So that E stands for sum. What does this X stand for? What's the difference between X and X with a little bar on top of it? Well, X stands for all of your data items. So, data items. All right, it can be a data item or data item. So let's see what that says. It says to find the mean, you sum all of the data items, R, and divide it by, what do you reckon the value N stands for? The number of data items. So I've actually just sort of tried to make it a little bit clearer here by sort of matching up the bits of the Barry formula to the worded formula. Sadly, you've got to remember all of this stuff, or you can write it in your summary book if you're in Australia. But let's have a look at an example extracted from the Cambridge Further Mathematics textbook series. And thank you so much, Cambridge, for allowing me to use your examples. I am stoked. You have some awesome, awesome textbooks there. Okay, so the following is a set of reaction times in milliseconds, 38, 36, 35, 44, blah, 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 blah. Write down the values of the following correct to one decimal place. So A, N. What did N stand for? The number of terms. 1, 2, 3, 4, 5, 6, 7, 8. So N is 8. I am stoked. Next one is this EX. Now that's a fairly funky looking E. So let's try that one again. E of X. So what does the E stand for? Sum of X, sum of all my X values. So I'm going to fire up my CAS calculator and I'm going to do 38. We're going to plus 36 plus 35 plus 43 plus 46 plus 64 plus 48 and plus 25. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Press enter and 335 comes out. And there we go, ladies and gentlemen. 335 is my E of X. See, what on earth is this X bar? Well, that's that Barry thing, that sort of find the mean. And we know that the mean is given by E of X divided by N. So 335 divided by 8. Firing up my calculator, 335, divide that by 8, gives me 41.875. Now, do I do my answer that way? Nope, because it says correct to one decimal place. So I will write 41.9, and lo and behold, there are my answers. Difficult? No. Now, why do we have the mean and the median? We've decided they are both measures of center. But which one do we use? Can we use both of them? Is there one that actually is the best to use in a particular circumstance? And yes, 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 yes. Now, when we go back to this previous example, if you remember, when I did earlier, we found the mean was equal to 5 and the median was equal to 4.5. Both of those are roughly the same. And for that particular data set, we could use either of those values. No big deal, we could use either of them to describe. Now the median, as I say here, is the central value of the distribution. It's the middle point of the data. And ask yourself a question. If I was to add a big value onto the end, if I was to put an outlier, if I was to put 100 on there, would it make a massive difference to my median? Probably not. It might shift it one space over. But the chances are the impact on my median would not be very, very big. If I add that 100 on to my mean, what do you think is going to happen? Well, bearing in mind this here all added to 30, when I divided it by 6, it gave me 5. What do you think 130 divided by 7 is going to be? Now, you're going to say, where did you get the 130 from? I've just added 100 on to all of those values. I'm now dividing by 7 because there's 7 data items. And yes, that value now is going to be almost twice as big. It's going to be almost 9 point something. Yeah, so that one figure, that one outlier has massively changed my mean. So in which case, the median would make more sense to be my center. It's the one that's sort of still stayed roughly the center. Now, if we look at these two graphs here, hopefully you can see that the shape of the graphs are very different. This one here is roughly symmetrical, and this one here is most definitely positively skewed. So if we looked at the measure of center, if we looked at the median for this data, hopefully we'd have it somewhere around here. Now, because it's symmetrical, that means an equal number of data items lie roughly either side of my median. And if I was to then work out the mean of this, I'm telling you it would be very, very similar, or it wouldn't be too far away. So for symmetrical data, my mean and my median would be roughly the same. Well, that's good. That means I can use either of them. If we look at positively skewed data, then we have a bit of an issue. Because if we looked at roughly speaking where our center is, I would estimate our center would be roughly around here. And again, it's just rough. But would my mean lie close to that line? And I'm going to say to you no. The reason being is because of those two massive values at the end. As soon as we have massive values either side of my mean, or either side of my median, it's going to start to change things. So in this situation, I would not want to use my mean because it's going to be affected by these massive values here. So the mean is out. My measure of center would be my median for that particular piece of data item. When do I know which is the best one? Well, I've pretty much just said that. Yep. The median is what we call a resistant statistic, right? A resistant statistic. Why is it resistant? Because when I have outliers on the end, it's no big deal. It doesn't get massively affected by outliers. That's the median. But the mean, wow, mean gets massively affected. Look about house prices. You know, which would you use there? Would you use the median or the mean? Well, if you look at house prices in any particular suburb, Melbourne, Sydney, anywhere in Australia or in the world, the chances are you're going to have a lot of houses who are going to be roughly grouped, sort of cheap, a lot of cheaper houses. And then you're going to end up with a few really, really expensive houses, or a small pocket of a suburb that for some reason, like Brighton here, will just be $1 million homes. Well, again, these here will massively affect my mean, making my mean not a very good measure of center. So in that situation, I would use my median. And again, if I've got data that is symmetrical, that is roughly centered around the middle point there, like the median, and we've got roughly the same shape either side, or to be honest with you, I can use the mean or the median. It doesn't bother me at all. Now, back to measures of spread, ladies and gentlemen. We've spent a lot of time looking at measures of center. We're going to go back to measures of spread. And we've said we can have the range, which is the difference between the biggest and the smallest value, and the interquartile range. Now, what was the interquartile range? We have a bit of a recap here with the most beautiful box plot. But remember the box plot. The box plot splits our data into sections of 25%. And the interquartile range, if you remember, was that middle 50%. We wanted to look at the difference between the highest part of that and the lowest part, Q1 and Q3. Now, what did we notice our data was centered around? It was centered around the median. So the interquartile range is centered around the median. That's great. But what about if we wanted to center things around the mean? Well, ladies and gentlemen, we come to something called the standard deviation. And Barry, once again, has created something that's a bit like, huh? What's a standard deviation? And I'm like, don't worry about it. It's fine. Now, imagine I have a load of data items. I've taken some sort of survey, or I've plotted some sort of data, and this is the data I've got. I've completely made it up. Yes? Now, when we take the mean of all of those data items, remember what you're doing. You're adding them all together and dividing by how many data items there are. And you get the mean value, which is somewhere in the middle. So if I imagined now drawing a line somewhere in the middle of this, wouldn't it be good if we could sort of work out some sort of measure of how far away from my mean each of my data items is. And by that I mean, wouldn't it be great if we could measure that distance there, and 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 come up with some sort of average distance away? Well, those of you who have followed so far will go, well, hold on a moment. The mean is halfway between all those data items. So if I add all of these negative ones together, and then add all of these positive ones together, and then add the total of the positives and the total of the negatives, guess what you're going to end up with? Well, actually, you're going to end up with 0, because that's the whole point of the average. It's finding the average of all those distances. Well, that's not very helpful to me. And so what we can do is we have a very special trick in maths that any negative number can be turned positive by squaring it, so by timesing it by itself. So if I look at this data item here, if I was to take that little gap there, that negative gap because it's below the line, and square it, I would now end up with a massive line there. This would be twice as high. This one would be above and twice as high. This would be twice as high. This would be twice as high. This would be above the line but twice as high. See what I'm doing here? I'm taking all of my values and I'm effectively squaring them. And then I can add them all together, and all of these positive things, yes, give me some sort of average distance away from my dotted line. Now, if you're watching this going, I've got no idea what you're talking about, don't worry about it. I promise you, if you're understanding this, awesome. If not, there's a formula coming up which will do it all for you. And so then what we have to do is, well, we've added all of those together. We've taken all of those squares together. Yeah, so the square numbers together, and we have to do something about it. And we have to square root. We have to take the opposite. We square root everything to get it back to my original value. But then I have to make sure that I divide it by the number of terms. Standard deviation is basically a measure of roughly how far away from some average value each of those data items are. Again, if you didn't understand that, don't worry about it. What you need to know for this course is that the standard deviation, given by the letter S, is given by this fairly revolting formula here. But some of it you've seen before. Yes? Remember, we've seen this little E sign. So let's see what that actually means. This here says to sum. Now, when we see brackets, we know that we've got to do it aside. Remember what the X stood before? The X stood for a data item. So we're going to take a data item. We're going to take away the mean value for all data items. Then we're going to square it. So that's the top part done. We're then going to divide it by the number of data items minus 1. We'll come back to that in a moment. And when I've done all of that, I'm then going to square root it. Now you're looking at that going, this sounds horrific. And of course it is, but the good news is you've got a calculator that can do this for you. And I'm going to show you how to do that in a moment. Now, funny enough, when I was back in the United Kingdom, that bottom of that fraction was actually just the letter n, not n minus 1. And some tutorials online will use n. There won't be this minus 1 here. And my advice to you is to make sure that you always use the n minus 1. If you want to know why, for those of you who are freaking geniuses and want to know what's going on here, then actually the reason we do it is called Bessel's correction, and I've spliced something out of Wikipedia for you to read. By all means, pause now and read it. But I'm now going to show you how to use your CAS to find the standard deviation for a set of numbers. Now, this standard deviation we're going to use a lot in later parts of this course, so there is bits and pieces coming up shortly that you're going to need to know. But let's show our CAS calculator and let's go back to our main. And what we're trying to do here is, I'll go back to our menu. We are doing statistics. Yes, thank you very much. So I'm going to load up my statistics, and you notice I've already got a list in there from a previous tutorial. So I'm going to hit edit. And I'm going to clear all, and it's going to say, are you sure? And I'm going to say, I am indeed sure. And it's going to clear everything. Now, one of the peculiarities of this calculator is that for some reason, if I do the data in first and then change the name, it all goes a bit skew-if and it deletes everything. So what I'm going to do is I'm going to change the name of that list once. So I'm going to hit keyboard. I'm going to go to ABC, and I'm going to go HEIGHT. I'm going to hit T. Thank you very much. Hit EXE. And lo and behold, there is my height column. And I'm just going to put the data items in. So 176, hit enter, 160, hit enter, 163, hit enter, 157, hit enter, 168, hit enter, 172, 173, and 169. So 8 data items, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So they're all in. What do I do now? Well, I need to go and say, I want to do a calculation. Now, the reason we're doing this is probably better explained in later videos, but at this moment in time, we're going to hit one variable. And it wants to know, well, what's this one variable you're using? Well, I don't have anything in my XY or X list called list1. So if I open that down, what you notice is I suddenly see main/height. Don't worry about the main slash. The height is the thing we're dealing with. Frequency will do 1, and I'm going to hit OK, and up comes a dialog box. And believe it or not, while there is a lot of information in there, there's 2 things you need to know. The question says, determine the mean and the standard deviation of the women's heights correct to 2 decimal places. And the screen you can see now, or the dialog box, holds both the mean and the standard deviation for you to see. Now, obviously, we know that the mean is X bar, and if we look, and there's a red arrow pointing there now, X bar is equal to 167.25. Yay! So just reading off that top value, there's my mean done for me. Where is my standard deviation? What did my formula start with? It started with the S. And so what we see, well, yes, we can see an S with a little subscript X. Don't worry about that. The red arrow is now also showing you our standard deviation. So clearing that so I can write on my screen, we would therefore write that the mean was equal to 167.25. Now that's fine because the question says to 2 decimal places, and my standard deviation is given to 6.67. And ladies and gentlemen, believe it or not, that is the end of this thrillingly exciting lesson on, what did we say it was called? Come on, describing the center and spread of a symmetric distribution. So we now know the difference between when to use the median and the mean, and we've started to look at the idea that the interquartile range is a measure of spread about the median, and now this standard deviation, the one that we're going to deal with in the next video and probably lots more to come, is a measure of spread around a mean value. And we've not only looked at the formula for the standard deviation, we've realized that our calculator can work all of this out for me. Thank you so much for following. Hopefully you've enjoyed the lesson. Hopefully it's made sense. If you can, over there in just a moment will be a circle where you subscribe. And again, put a shout out if you would. It's greatly appreciated. Otherwise, the video is loading just below it. I am done. This is MaffsGuru signing off. I look forward to seeing you next time. Take care. MaffsGuru out.